It's a pretty happy day when a router receives an IP packet, looks at the IP destination address, and says, I've got a route for that. Well, in this video, we're going to take a look at two major options that the router can perform when it does have a route regarding the forwarding of that packet. And once again, we're going to leverage the hands-on lab. So we're on DCNUG, the admin PC, and we'll use mPuTTY and open up terminal sessions over to our routers. And we'll start here on router 1. So on router 1, let's do this. Let's do a show IP route space, and let's add on the keyword connected just to see what R1 is connected to. So if we were to take this output from show IP route, just include connected networks, this is R1, and we look at the interfaces. He's got a loopback interface. So that's there. He's got a gig 0 interface, so gig 0/0, and gig 10 and gig 20. Fantastic. So after all said and done, this router, if it's going to forward traffic, has 3 real choices and 1 logical choice, because loopback 0 doesn't really go anywhere. And from this routing table, we can identify the networks. So gig 00 is based on this right here, is 10.10. And the gig 2/0 interface is 10.13.0. with a 24-bit mask. I'll add that as well. And gig 1/0 right here is 10.12. This also, with these local routes, is also giving away what the actual IP address is on those interfaces, which this is R1 and all of its interfaces end in .1. And we can also use this backdrop here for a packet that is coming in. So a packet's forwarded to R1. Maybe it came in on gig 1/0, maybe it came in on gig 00, but in any case, the packet came in, and inside the IP header, if that packet was destined to 10.13.0.99, R1, when it looks at that destination IP address, is going to say, whoa, 10.13.0.99, I've got a route based on my routing table. Based on my routing table, these first 24 bits, this 24-bit network, matches that destination address. So the router is only comparing the first 24 bits because that's what it has the route for, this portion right here. And because it matches, the router says, great, I've got a route, and it is directly connected. And so what would happen is, off this gig 2/0 interface, the router is going to say, well, I'm not forwarding this to another router. I need to deliver it to the actual host on that local network. So at that point, if R1 did not know the layer 2 address associated with this IP address off this interface, it would do an ARP request. So the ARP request would go out saying, hey, broadcast, I need to know who has 10.13.0.99. And if it got a response, then the ARP caches would populate, and then R1 would at layer 2 forward the frame to that host, who would then de-encapsulate it, look at it, and do whatever that host was going to do with that packet. So that's the routing process if the router believes the destination is directly connected. Now, on the other side of the coin, what if the destination IP address matches a route which is not directly connected? So let's go ahead and clear the screen. And at the command line here on R1, let's do a show IP route and just press enter with no filters. And let's hit the space bar a couple of times and go all the way to the bottom. And let's pick this route right here, the 10.24.0 network. And we'll draw R1 again. So here's R1. A packet came in to 10.24.0.33. The router has this route for 10.24.0, which, when it compares it to this first 3 octets of that IP address, it's a match. The router gets a big smile on its face and says, now what do I do? Well, what it's going to do, it's going to use 10.12.0.2 as the next hop. It also shows here the interface. So the router has this interface gig 1/0, which is connected to the 10.12.0 network. And then he's got a good buddy right here at R2 who's got the IP address of 10.12.0.2. I'm just basing that based on this next hop address. Also, this matches many of the labs that we've been doing together. And that's going to be something you're going to find more and more comfortable. The more you work with the topology or a certain network, you kind of remember where things are. It becomes easier and more comfortable to work with. And that's what's happening here in our labs as well. So as we continue on with that packet that needs to go to 10.24.0.33, R1 says, okay, here's what I'm going to do. My next hop is 10.12.0.2. And if R1, and this is an Ethernet segment, so if R1 does not yet have the layer, he will. But if R1 does not have the layer 2 address of R2, it would ARP for it. But because we have lots of traffic that's going back and forth, that probably is already cached. And then armed with R2's layer 2 information, R1 would re-encapsulate that, including R2's layer 2 address in the layer 2 header, forward it to R2, and then R2 would receive that, open it up and say, oh, this is the packet for 10.24.0.33. And then it would go through the same process of comparing that destination IP address against its routing table, and then it would make a forwarding decision. One of the key things about IP routing is that once a router hands off a layer 3 IP packet to a peer, to another router, it doesn't care much anymore. It just hands it over, and then it's up to the next router in the path to figure it out and sort it out and make its own routing decision on towards the destination. So in this video, we've answered the question, if a router receives a packet and it has a route and it knows how to forward it, what does it do? Well, if it's directly connected to the destination network where that packet is going to, it'll go ahead and deliver it to the client, the server, the PC on that local network. It'll ARP as needed if that's required and deliver the packet. Now, if the network is not directly connected, where the packet needs to go, R1 in its routing table, if it has a next hop of another router, it'll then forward that frame at layer 2 to that next router, who will then receive it, look at the destination layer 3 address, and then make its forwarding decision. And one of the important elements to remember for us as we forward IP, or as the routers forward IP packets, is that we don't only have to have a path from source A to the destination, we also need to make sure there's a correct or workable path back so that reply traffic can come back. Because routing is a two-way street, and we need to make sure that both paths, there and back, are working if we want a functional network. So thanks for joining me in this video and lab. I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.